All right, in this video, we're continuing our polynomial review for the Unit 4 test. We're going to go ahead and pick up with question 5, which is asking us to find the coefficient of the fourth term in this binomial expansion. So I don't need the entire binomial, I just need the fourth term. I still have to know how to set it up, however. So I'm going to put the blanks for this polynomial so I know which line of Pascal's triangle I'm using and then where my numbers are coming from. So I'm raising this binomial, 4x plus 2, to the 7th power. I'm going to go back to the Pascal's triangle that I made in the last video for question 4. Here we go. So this is Pascal's triangle for question 4, and we're raising our term to the 7th power. So again, I'm going to need this bottom row from Pascal's triangle, which again tells me that I need 8 terms altogether, and their coefficients go 1, 7, 21, 35, 35, 21, 7, 1. So let's go ahead and set up our blanks here. We're going to need 8 terms. 1, 2, 3, 4, 5, 6, 7, and 8. I don't need all of them. The only one I really care about is the fourth term. So I need 1, 2, 3, 4. I need this one. So I'm going to use the other ones as guidelines to help me understand which numbers go here, but the only one I'm going to focus on and simplify is the fourth term. So the first thing I'm going to do is take a look at Pascal's triangle to figure out which coefficients go in. Those coefficients were 1, 7, 21, 35, and then it went 35, 21, 7, and 1, but I don't care about those numbers. So I'm going to stop once I get to that fourth term. I need the number 35. Now, my term will also need an A term and a B term, and those are going to come from my binomial. My A term is whatever's in front, 4x, and my B term is whatever was in the back, 2. That's a 2. Okay, so we have a 35, we have 4x, and we have a 2. Now all I have to do is figure out what my exponents would be. The most helpful way to figure out that pattern is, again, to start at the beginning and detail what the exponent would be. There are going to be 2 terms here, a 4x and a 2. The 4x is going to start with the highest power of my binomial, which is 7. And then it's going to count down 6, 5. By the time it gets to this fourth term, it's going to be down to the number 4. So that's going to be 4x to the fourth power. Now let's take a look, because then I would count down 3, 2, 1, 0. But again, I don't care about those. So I'm going to stop once I get to the number that I need. For my last term, it would start with the opposite pattern. Instead of starting at 7, it would start at 0, and then we'd count up. 1, 2, 3, and then we'd continue with that pattern 4, 5, 6, 7. But again, I don't care about anything but this middle fourth term. Now that I have it set up, let's go ahead and take a look at simplifying it. So the 35 will be the number 35. 4x to the fourth means 4x times 4x times 4x times 4x. I have to do 4 times 4 times 4 times 4, which is 256. And then x to the fourth as well, which is going to be x to the fourth. My next term, 2 to the third power, 2 times 2 times 2, is the number 8. So these are the 3 numbers that I have to multiply together to get this fourth term with its x to the fourth. So in the calculator, if I do 35 times 256 times 8, I get the number 71,680, which is the coefficient of x fourth, and all I care about for this problem is the coefficient. I don't actually care about the fact that x is being raised to the fourth power. All I wanted to do was find that number. For question 6, we want to find the entire term, not just the coefficient. But again, we only want the third term for this problem, so I don't have to simplify everything. Once I get my problem set up, I only have to focus on and simplify the third term. So this binomial is being raised to the fourth power. If I take one more look at Pascal's triangle, that again is this row right here, I'm going to have 5 terms. So 1, 2, 3, 4, and 5. And for this problem, we only care about the third term, which is right here. So let's see how we would set that up. The numbers from Pascal's triangle for the fourth power have the number 4 in them. So it's 1, 4, 6, 4, 1. And again, I only care about this term. So let's see what else I would fill in here. I need to have my A term and my B term. My A term comes from the first thing in my binomial, which is negative 3x. That's a 3. My next term comes from the last thing in my binomial, which in this case is a positive 5. And let's check to see what exponents we'll be using. My first term, which would be 3x over here, would start being negative 3x, would be raised to the fourth power. In the next term, it would be a 3, so by the time I get to this term, I would raise that to the second power. My 5 would start with the 0 power, then count up to 1, then 2, and then 3, and then 4. So I can stop right here at my third term. Now that we have this term set up with its coefficient from Pascal's triangle and the proper exponents, let's go ahead and simplify. 6 is just the number 6. I'm going to have to multiply that by negative 3x squared. So negative 3x times negative 3x, which is going to be positive 9, and then x squared. And then I'm going to have to multiply that by 5 squared, which is 25. So if I try that in my calculator, I'm going to end up with 1,350 and x squared. And I want to keep the x squared this time because I want the entire term, not just the coefficient. All right, that is it for our binomial expansion problem. So we're going to pick up with some division in the next video.